In this video, we want to cover the first part of section 4.5, exponential and logarithmic equations. This section is kind of long, so we're going to do exponential equations in this first video, and we'll do logarithmic equations in a second video. So our first equation here is going to be 5 raised to the 2x plus 3 is equal to 1/5. For a lot of these problems, if we can, we would like to make the expression on each side of the equation have the same base. So in this problem, we have 5 as the base on the left. And then we can rewrite the right side to have 5 as a base as well. So this is 5 raised to the 2x plus 3 is equal to 5 raised to the negative first power. Once we have the same base here, this will be equal if the exponents are equal. So we can set the exponents equal to each other. 2x plus 3 is equal to negative 1. If we subtract subtract 3 on both sides, we get 2x is equal to negative 4. Divide by 2, and we get x is equal to negative 2. We can do a similar problem here for number 2. So if we have 3 raised to the 2x plus 1 is equal to 3 raised to the x minus 1. Again, we have the same base, so then we can just set the exponents equal to each other to solve for x. All right, if I subtract 1 on both sides, we get 2x is equal to x minus 2. And then we can subtract x on both sides, and we get x is equal to negative 2. That was coincidental. I did not mean to do that with getting x equal to negative 2 on both of these. But we can carry on and do a little bit more difficult problem here. 2 raised to the 2 minus x is equal to 9. We want to solve this exponential equation. Note here we cannot rewrite 9 as some expression with base 2. So instead, we're going to use logarithms to solve for x. And here, we want to do this by either taking the natural log or the log base 10 of both sides. We generally take either the natural log or log base 10 because often our calculators are programmed to handle those pretty easily. Any other base, we may need to do a change of base formula. So generally it is best to just use either natural log or log base 10. I prefer natural log, so I will use that every time. So again, how do we solve this? Well, we want to take the natural log of both sides. So let's do that and see what happens. Well, we had an x up in the exponent here. So now we can move that down. So this 2 minus x was our exponent, so we can move that down and multiply. So this is 2 minus x times the natural log of 2 is equal to the natural log of 9. And now we just need to solve for x. It's no longer an exponent, so this is relatively easy. So this statement is true if and only if 2 minus x is equal to ln of 9 divided by ln of 2. We want to solve for x here. So this tells us that x is equal to, if we move the x over to the right and this over to the left, that looks like 2 minus ln of 9 divided by ln of 2. And so we found x. I want to continue on and do an example 4 here. So now we have e raised to the 8 minus 9x is equal to 14. Again, we want to take the natural log of both sides. So the natural log of e raised to the 8 minus 9x is equal to the natural log of 14. All right, so we can again drop the exponent. So this is 8 minus 9x times ln of e is equal to ln of 14. This is 8 minus 9x. And then what is ln of e? Well, that is just 1. So this is 8 minus 9x is equal to ln of 14. Okay, and that gives us the expression, or the equation, excuse me. 8 minus 9x is equal to ln of 14, so we can solve for x here. So we get 8 minus ln of 14 is equal to 9x. So this tells us that x is equal to 8 minus ln of 14 divided by 9. We're going to keep going. I have a couple more examples still from this section. The next one is going to be 9 raised to the x plus 3 to the 1 plus 2x is equal to 20. Now this one is a little tricky, but what we can notice is that 9 can be rewritten as a base 3. So this is 3 squared, all of that raised to the x, plus 3 to the 1 plus 2x is equal to 20. We can rewrite this 3 squared raised to the x as 3 to the 2x. Also, we can rewrite 3 to the 1 plus 2x as 3 times 3 to the 2x. Oh, now we have a 3 to the 2x and a 3 to the 2x. So now we can factor out that 3 to the 2x. So if I factor out 3 to the 2x, we're left with a 1 over here, right? If we divide by 3 to the 2x, that would be 1. And if we divide by 3 to the 2x on this term, we get 3. So this is 3 to the 2x times 4 is equal to 20. We can divide by 4 here and get 3 to the 2x is equal to 5. And now this is like our previous two problems where we can just take the natural log of both sides. So this is the natural log of 3 raised to the 2x is equal to the natural log of 5. And this tells us 2x times the natural log of 3 is equal to the natural log of 5. So we get x is equal to ln of 5 divided by 2 ln of 3. Our next one is going to be 3 raised to the 7x plus 1 is equal to 7 raised to the x minus 3. All right, this is, again, we take the natural log of both sides. This is the natural log of 3 raised to the 7x plus 1 is equal to the natural log of 7 raised to the x minus 3. We can we can bring down these exponents. So this is 7x plus 1 times ln of 3 is equal to x minus 3 times ln of 7. And now we need to solve for x. So we need to first distribute here. This is 7 ln of 3 times x plus ln of 3. And this is equal to ln of 7 times x minus 3 ln of 7. Once we have the equation written out like that, we can move all the x's to one side, move everything without an x to the other side. So this is 7 ln of 3 times x minus ln of 7 times x is equal to negative 3 ln of 7 minus ln of 3. Factor out an x and then divide, and we get x is equal to negative 3 ln of 7 minus ln of 3 divided by, right, we factored out an x here, so what's left over is 7 times ln of 3 minus ln of 7. And so we solve for x. We have one more example that we want to cover from this first half of 4.5. So I will do that here. And this is going to be something called an exponential equation of quadratic type. So we have what kind of looks like a quadratic equation here. We don't really see that yet, but we can show that soon. Again, this is called an exponential equation of quadratic type. So to see that this really is a quadratic equation, notice that 8 to the 14x is the same as 8 raised to the 2 times 7x. And then we have an 8 minus 8 to the 7x minus 56 is equal to 0. That is the same as 8 to the 7x squared minus 8 to the 7x minus 56 is equal to 0. So this will look like a quadratic equation. Really, if a is equal to 8 raised to the 7x, then in fact, this here is a squared minus a minus 56 is equal to 0. This is something you know how to handle. Right? We can factor. This is a minus 8 times a plus 7 is equal to 0. For that to be true, either a minus 8 is equal to 0 or a plus 7 is equal to 0. So this is a is equal to 8, a is equal to negative 7. Let's handle one of these at a time. A is 8 raised to the 7x. So 8 raised to the 7x is equal to 8. If we have the same base here, then we set the exponents equal to each other. So 7x is equal to 1, or in other words, x is equal to 1/7. Alternatively, if we use the other term to be 0, we say the other term is 0, then this is a, which is 8 raised to the 7x, is equal to negative 7. But this is an exponential function, and exponential functions are always going to be greater than 0. And so this is, well, if the function is a positive out in front, it'll always be greater than 0. So this can never happen. So in fact, our only solution is x is equal to 1/7. And that's it for this video. Again, we'll have a second video covering the second half of section 4.5.